Hello and welcome. Our task for today is to solve this long logarithmic equation for x. On looking at this equation, you will notice that we also have x, the unknown, in the base of the logarithms. So the first step to solving this equation will be to change the base using our change of base formula. Now that formula says that if we have a logarithm to base a of a number b, that this is equal to log to base n, where n is the new base of the number b, divided by log to base n of the old base a. In doing this, we have changed from base a to base n. But back to the equation we have at hand. The question now becomes, what is the best base for us to change to? Now you can see that this is 4x. 4 is 2 raised to power 2. This is 16x. 16 is 2 raised to power 4. And this is half x. Half is equal to 2 raised to power minus 1. So I think that it would be best for us to work in base 2. So applying the change of base formula to this equation, we have that 40 times log to base 2. Now remember that we can write square root of x as x raised to power half divided by log to base 2 of 4x minus 14 times log to base 2 of x raised to power 3 divided by log to base 2 of 16x. Now let us bring this term over to the left hand side. So we have plus log to base 2 of x squared divided by log to base 2 of half x, and everything is equal to 0. Next, to simplify this expression, let us apply the power law of logarithms. That law states that log m raised to power n is equal to n multiplied by log n. Applying this law, we have that we can bring down this half to multiply, and you know that half times 40 is 20. So we have 20 times log to base 2 of x divided by log to base 2 of 4x minus 3 times 14 is 42. So we have 42 times log to base 2 of x divided by log to base 2 of 16x, and plus 2 times log to base 2 of x divided by log to base 2 of half x, and everything is equal to 0. Now when you look closely at these three terms, you can see that we have a common factor, because we have log to base 2 of x, log to base 2 of x, log to base 2 of x. And not only that, this is 20, 42, and 2. The three numbers are even, so they are divisible by 2. So that means that we can factorize 2 times log to base 2 of x, and we have 10 over log to base 2 of 4x minus 21 over log to base 2 of 16x plus 1 over log to base 2 of half x is equal to 0. Now when you look at this line, you will see that we are multiplying two things. We are multiplying 2 times log to base 2 of x into this term, and we are getting a product of 0. So that simply means that either this is equal to 0 or this is equal to 0. So we have from this statement that 2 times log to base 2 of x is equal to 0, from where we have that dividing both sides by 2, log to base 2 of x is equal to 0. So at this point, we have already found one of the roots of this equation, which is that log to base 2 of x is equal to 0. So keep this in mind. What we now do is to go on to solve this part of the equation. The next step to solving this equation is to further simplify this expression by using the product law of logarithms. We know that when we have log a multiplied by b, that this is equal to log a plus log b. And here we have 4 multiplying x, we have 16 multiplying x, and we have half multiplying x. So we can write this out as 10 over log to base 2 of 4 plus log to base 2 of x minus 21 over log to base 2 of 16 plus log to base 2 of x plus 1 over log to base 2 of half plus log to base 2 of x is equal to 0. Now this can be written as 10 over log to base 2 of 2 squared, because 4 is 2 squared, plus log to base 2 of x minus 21 over log to base 2 of 2 raised to power 4 plus log to base 2 of x plus 1 over log to base 2 of 2 raised to power minus 1 plus log to base 2 of x is equal to 0. Now, once more, applying the power law to this, you can see that we can write this as 10 over 2 times log to base 2 of 2 plus log to base 2 of x minus 21 over 4 times log to base 2 of 2 plus log to base 2 of x plus 1 over minus 1 times log to base 2 of 2 plus log to base 2 of x, and everything still remains equal to 0. Now, having expressed it in this form and recalling that log to base a of a is equal to 1, we have that 2 times 1 is 2, 4 times 1 is 4, and minus 1 times 1 is minus 1. So we can now write this as 10 over 2 plus log to base 2 of x minus 21 over 4 plus log to base 2 of x plus 1 over log to base 2 of x minus 1, and everything still remains equal to 0. Now, let log to base 2 of x be equal to y. So from this last line, what we have is that 10 over y plus 2 minus 21 over y plus 4 plus 1 over y minus 1 is equal to 0. So now this is the equation we have to solve to get values of y and hence values of log to base 2 of x. Now to solve this equation, we need to combine these 3 fractions into one single unit, and this is how we do it. We have 10 into y plus 4 multiplied by y minus 1 minus 21 into y plus 2 multiplied by y minus 1 plus 1 into y plus 2 multiplied by y plus 4 everything divided by the product of this and this and this, which is y plus 2, y plus 4, and y minus 1. Of course, everything is equal to 0. Now, to solve this equation and find the values for which this is equal to 0, what we have to do is to solve the numerator. Expanding the numerator, what we have is 10 into, this is y squared minus y plus 4y minus 4 minus 21 into y squared minus y plus 2y minus 2 plus y squared plus 4y plus 2y plus 8, and everything is equal to 0. Collecting like terms, we have 10 into y squared minus 4, or rather minus y plus 4y is plus 3y minus 4 minus 21 into y squared minus y plus 2y is plus y minus 2 plus, we have y squared plus 4y plus 2y is plus 6y plus 8 is equal to 0. Now, multiplying by the coefficients, what we have is 10y squared plus 30y minus 40 minus 21y squared minus 21y plus 42 plus y squared plus 6y plus 8 is equal to 0. Now, collecting like terms, we have 10y squared minus 21y squared, that is minus 11y squared, then plus y squared, that is minus 10y squared. We have 30y minus 21y, that is 9y, plus 6y, that is plus 15y. We have minus 40 plus 42, that is plus 2, plus 8, that is 10, is equal to 0. Now we can divide everything by minus 5. When we divide this by minus 5, we have 2y squared minus 3y minus 2 is equal to 0. Now we can factorize this quadratic equation, because we know that the factors of 2y squared are y and 2y, because y times 2y will give you 2y squared. And the factors of minus 2 are minus 2 and 1. Now let us check for the middle term. Y times 1 is y, and y, or rather minus 2 times 2y is minus 4y, and minus 4y plus y will give you minus 3y. So that simply tells us that the factors of this quadratic equation are y minus 2 and 2y plus 1. And of course, this is equal to 0. Now, from this equation, we have that y is equal to 2, or 2y is equal to minus 1, and hence y is equal to minus half. But let us not forget that y is only standing in place for log 2x. So this means that log 2x is equal to, remember that we already got 0 as a root of that equation. 0, 2, or minus half. Now we have that log is equal to 0, 2, or minus half. From this statement, we know that x is equal to 2 raised to power 0, or 2 raised to power 2, or 2 raised to power minus half. Hence, we find that the values of x that satisfy this equation are x equal to 1, because 2 raised to power 0 is 1, or 4, or 1 over square root of 2. So these are the values of x that satisfy this equation. This has been a rather long one. I hope you enjoyed the exercise and I hope you learned something. Remember to subscribe, leave a like to support the channel, comment if you have any question or any observation, and see you in the next one.